support engineer and trainer for simulation products at MCAD Technologies. Thank you for being here for this webinar on flow simulation post-processing. I do want to present some items that you may not be familiar with that should help you enhance your output from the program. Our time today should be about 30 minutes or less. So let's get started. So on the agenda today, what we want to show are some ways to creatively present flow simulation results, including customizing color plots for readability, side-by-side comparison of specific results for multiple projects, and animating trajectories and plots together with model rotations. Then I'll add some special effects to wrap it up. Let's start by working with results plots in the graphics area. Many ways exist to customize and manipulate plots to allow you to clearly post-process and present your results. We'll focus primarily on the color bar and its settings to start things off. So let's switch over to the SOLIDWORKS interface. And looking at this model of an automotive intake and exhaust system, we've set up 3 design configurations with the objective of maximizing the mixing of the air and exhaust streams. We've loaded the results for the default configuration representing the original design, which is shown here. So showing some of the setup information in here, we've got an inlet condition where we have, we're making the use of substance concentrations. We've got air and exhaust gas in this model. And so using mass fraction values, we've got a mass fraction of 1 entering at the upper inlet. And then for the exhaust, we've got a mass fraction of 1 for the exhaust concentrations there. And environment pressure is applied at the outlet. So the mixing gets done here in the lower end of the intake pipe, and we're going to study the effects of that with our output results. Several goals have been set up. It's common to use goals of global and surface goals. So we've got those as a set up to help with the model convergence. Results are loaded for this model, and so what I want to do is show you some information on how to work with the color bar for the plot. So what I'm going to do is show all of the show all of the flow trajectories. So here we see the typical color bar that gets established when we do so. These 2 plots of the trajectories are showing common values, so they get grouped together here in the color bar. In the one trajectory for the inlet air, we've got solid lines representing those trajectories, and then we've got lines with arrows on the exhaust side. One thing you'll notice, if you need to make different color bars for examples like this where you're showing the same parameter, it's possible to split those color bars out. So here you see the split out for the exhaust side. Just drag and drop that wherever you'd like it. This allows you to make different settings for the 2 color bars. We're going to stick with 1 in this example, so what I'll do is I will merge those back together. And I'll use the settings for the inlet air color bar. You're probably aware of the ability to change the range of values shown here. We can either use the drag of the slider, the lower and upper ends, or we can use icons in here that represent different values. The left icon would represent the minimum value for the entire model. The right icon would represent the value associated with this particular plot that we're viewing. So what I'm going to do is I'm just going to manually shift that down to a value of 0. And then for the upper bar, we see we have a value of 1. So we get a good 0 to 1 range there. Now, another thing that we can do here is work into the right-click menu and go into the edit mode. You have those same abilities to change those values here for the minimum and maximum. But we can also customize what we see in the color bar in terms of the number of levels, the color palette that we want to use. So what I'm going to do is, what I want to do is change this down to 16 levels so I get some hard lines there where we get the transition to the different values. And we'll just go ahead and apply that. And then in terms of another right-click menu, we can look at the appearance in here. So we've got a lot of intermediate numbers in there. And what I'd like to do is change that to a maximum value of 8. So I've got 16 color gradations there, and I've got it set to show me 8 values. The font is a little bit faint also, so I can switch over to from the default font to whatever I'd like. I have the standard Windows-based changes that we can make there for fonts. So what I'm just going to do is just make that bold and maybe a little bit bigger, maybe go up to 11 point. You see we get the update there. All right, so other things that we can change here, palette size, height, and width. And that's also able to be done with a drag on the edge of the plot here. So if I activate it, you'll see I can change that, just manually change that with the drag. So you get that set up just like you like it, and for readability, and then you're all set there. So another thing that might want to change here is we have 4 significant digits shown. For this particular value, it's probably not necessary. So what I'm going to do is go into the units for the project, and I'm going to look for that particular output. I believe that's going to be under the medium properties. Let's see if I've got that right. Concentration. So here's my concentration setting for the units. I'll just put that down to point, to single decimal point, and we get the update there. So a nice looking customized color bar that can be used to make things show up better in your reports and your outputs. Switch back over to the presentation here. And let's move on. A new feature that came out in the 2013 release allows side-by-side comparison of data across multiple projects. So let's take a look at this compare function inside the SOLIDWORKS interface. Here you see we have our plot as we left it for the trajectories for this model, and I can use the new compare function to look at this information, the same information across the 3 configurations. For the extended, if I activate the extended exhaust configuration, you should see in the area here a small pipe that gets extended out into the air portion of the system. And then looking at the turned exhaust configuration, activating that, we see we have a nice elbow in there to turn the flow of the exhaust as it enters the system. So switching back into the default configuration where I have my plot set up and ready to go, I can use this compare function to look at side-by-side comparisons of these items. So let me get this, move this up a little bit so it's readable, and bring that down. So get things looking like you want it in the display area, and the active scene is what we're wanting to compare. We can also compare things like surface parameters, goal plots, and this also would apply to the other items in the results tree, like your point parameters as well, and volume parameters. So looking at the active scene, which would be this plot, and I think it might be a little cleaner if I take the interface and maybe do some things to minimize that. Move it over a little bit. So there's our active scene, and I'm going to run the comparison for all 3 configurations, all 3 projects, over here in the list to compare. It is a post-processing utility that runs, and so it's doing that now and going to get all the information from the other configurations, the other projects, and once that's done, we'll be able to see the results. Here we go, progressing along with the bar on the bottom. Get some white out of the screen there, I guess, because of the presentation mode of the screen sharing. When this comes back, we should have the information we're after. As I mentioned, this compare can be done for other things like the surface, volume, and point parameters, other useful tools that also interact with the Excel spreadsheet function. So make use of those if you haven't explored those yet. So here we go. We're loading some results, and we should be all set. So switching over to the active scene, you see we have the 3 side-by-side plots. Just drag that up a little bit, and you'll see those a little better for those 3 plots. Now, these can also be saved out to files, out to your results folder. Just give that a location, and you get these saved out. I should also be able to double-click on these and bring them up directly. So there you go. That's our compare function. Very nice utility introduced in the last release. All right. Let's take a further look, a little bit more detailed look at the flow trajectories and their setup. They're especially useful in visualizing the flow characteristics. Their settings are important depending on what you're visualizing with them. So I'm going to switch over into SOLIDWORKS and check that out. All right, so flow trajectories, as you probably already know, are set up. Let me go ahead and pick one of the faces of the lids. Show the lids here. So, for instance, I'll grab one of these interfaces using the Select Other tool. And there's the interface of the lid. Going and setting up a new trajectory based on that face. We basically give it the number of points that we want to look at across the area that we've selected. Now, one thing we can do is base this also on a sketch. So if you had a particular pattern of points that you wanted to force the program to use, a sketch could be used to do that. Say you had an annular region that you wanted to explore, you could put several concentric rings, several concentric circles on a sketch and use that, and it would distribute those points that you specify uniformly along that. So the default is to use pipes and just running that with the pipes. There's our default setting. And here we are again with our color bar that's showing the generic setup. It's looking at pressure. Right now we can change that with the settings here. We can go and look at overall velocity if we'd like. Excuse me. All right, so some of these are more conducive to animation than others. Right now, like I say, we're looking at pipes. The ones that are more conducive to animation would be the lines with arrows and the spheres. So keep that in mind if you're animating things. So I can show you basically how this looks in an animation mode. Go ahead and close that. we can quickly play animations directly from the graphics area. And as you notice, they start from the surface that we've picked for the setup of the trajectories and the end wherever the flow ends. So and the next subject of my presentation would be digging a little bit more into animations themselves. So there's multiple ways we can do so. We can do that directly on the plots, as I showed you just a moment ago, in the results tree, or we can create enhanced animations using the timeline at the bottom of the screen that's similar to the one that you may be familiar with in the SOLIDWORKS animator. So let's take a look at that. All right, so for a given category of animations, let me go ahead and just suppress this one since it's a duplicate. Go ahead and delete it. For a given category, we can play all of those particular animations. So I've turned that on for these two. We have a button here to stop them all down in the graphics area. Stop all animations. Another thing you can do, let me get it playing again. Another thing you can do is just hide all the animations. That stops things and hides everything. So several ways to control what's going on there. So one of the other plots that I have here, surface plot on the outlet profile, that will give me that mass fraction number you see here. So there again, I'm going to control select these, and I'm going to use my merge. Oops, picked in the wrong area. You do have to pick over the color bar area to select these with control, and then to do your right clicking, I'm going to merge those, and I'm going to use the one on the left. So now I've got those nicely merged. To be showing you the profiles. There we go. Okay, so in addition to the trajectories, I've got the surface plot at the inlet, at the interface of the outlet lid. That gives me a good ability to visualize what's going on, and the concentrations are right there at the outlet. Another thing that we have that you should be aware of is we have a plot manager. So in this case, I've got the 3 different plots shown. I've got that outlet profile plot. I've got 2 trajectories shown here. This is an overall manager that allows me to control those. So if I wanted to, for instance, turn off the trajectories, I can do that here with a selection. And then I'm just end up with the outlet profile plot. So it's kind of a handy interface to do a good control with all the plots that you have there. All right, so we're on the subject of animation. So what I want to do is control the display of these things with the animation itself, animation toolbar itself. If you notice, let me just go ahead and hide this last one. If you notice, I have a saved animation here, and if I play that, we have some settings to both manipulate the zoom level of the model as well as showing the plots with the control of the timeline. Let this load up, and it'll play that, and then I'll show you how we can dig into that. Set that up from the start. So here you see the model zooming into the inlet areas with some surface plots shown there, showing in the overall concentrations. And there we see the trajectories for the air inlet coming down as we zoom into the area of mixing, and here comes the exhaust gas. And then finally a display of the surface of that with concentrations. So if I expand the control here, you'll see how that was set up with this time bar. For the sake of time, I'll just show you the key points and how those were set. Notice we have all of the results plots that are available to us here. The total would represent the total model, inside surfaces of the total model. That's when you saw the, let me go ahead and play it up to that point. So see here we're showing that plot actually of all of the concentrations on the inside surfaces. Moving along on the time bar here, that gets turned off, and then trajectories get turned on. In this case, I've turned on the air side trajectory animation. And we have a key point here that would give us a new position in the model. So as you see, when it gets to this point on the timeline, the zoom will stop and then reverse, as you see there. So now we're going to a new key point out here with the time bar, and we've started the trajectories for the exhaust with this timeline here on the exhaust side. Those are coming along there. And then finally, we turn on this surface plot at the very end here, so where we see the exhaust concentrations. And that is the time bar that's similar to the SOLIDWORKS Animator. Very useful tool for setting up your animations with model rotations and movement. Now another way to capture video in a more manual way is to use the record video function, which is fairly new. Within the right click of the results category, we have the record video, and it basically opens up the same interface where you have the capture area. I didn't point this out before, but we have this red outline that is the capture area, and that can be resized and moved around. Should be able to drag that around, so you can capture just what you want. So zooming in there. Now whatever you do when you start the recording, that is what gets captured. It does not capture any of your mouse movement, so it will capture those highlighting faces in there as I'm rolling over things. But you know, I can do things like turn on this ISO surface plot, which shows me the concentration of the exhaust gas. Looks like I'm clipping away the color bar here, so should be able to drag that in. Let's drag that into an area where we can see that a little bit. And then editing the definition of that, it's set right now to a value of 0.25 on the concentration. So if I use my preview button there and I change the value, you'll see it update real time in the graphics area. So I can go all the way down to 0, start down there, and then zoom back up to the value of 1 as you see the video capturing the updated graphics area. So I'll stop that recording. Let's go ahead, and I had done this before, so I'm going to replace that video. And let me go pull that up, bring that up. All right, here it is. There's the recording we just made, doing it in a manual mode. You see the faces highlighting as I hovered over them, and then we should see that ISO surfaces plot show up. So it literally captures the screen of everything that's happening there. It doesn't grab the property managers, and it just does a fairly nice job of letting you capture sequences of operations or hiding and showing things. Now we see the plot update as I've moved that slider, and it is still shown over here. I'm just going to X out of that. Oops, I lost my video. There we go. And there's the update. So you could set this up to where you're ready to move the slider and just show that animation very nicely. And X out of the record video mode. And the last thing I wanted to show you were a couple of special effects type items that can be leveraged to put a special touch on visualizing results. There's a trajectory pulse animation using spheres that is useful for external flow problems. And then there's an XY plot in the results that we can access. And I'll show you those two now. I grabbed a model off of the 3D Content Central site. I grabbed a model of a soccer ball and ran a little external flow study on it. Basically, the parameters are, gave it a velocity 40 miles per hour, so pretty solid kick on the soccer ball, and the computational domain you'll see here. There's the computational domain. So we've got that velocity in Z, so the ball would be moving in the plus Z direction for the simulation. So let's take a look. All right, a goal on the maximum velocity. Got the results loaded up here. And let's see, a cut plot. There you see a cut plot with a couple of things added to it. We've got vectors representing the velocity as the air moves over the ball. And we've got the velocity contours shown as well, from 40 to 47 miles per hour. All right, so just go ahead and hide that. And what we can do is, on the animation side for the special effect I was referring to, what I have is a trajectory plot that's just filled with spheres. I've got, I think it's 4,000 spheres here, and this is what you need to, how you need to set it up to do what I'm about to show you. So it's just cluttered with the spheres. Go ahead and hide that. And then if I go into an animation mode, zoom in a little bit more to get the effect we're looking for, we can insert an animation of that. Here's the flow trajectories. I'm going to right-click here and insert a control point. And then you just, as you insert it, it's waiting for you to tell it where the endpoint is. So I left-click at the 10-second mark. And then the key here, to get this effect that we're looking for, is to go into the properties of this, and we're going to use this impulse mode for the properties of those trajectories. And I'm going to send that pulse of trajectories of spheres every 3 seconds. So then animating that, you get kind of a neat effect to where the ball appears to be flowing through like a wall of air, so to speak. So you see those pulses going there into the flow trajectories. So that can be useful for some external flow type problems for enhanced visualization. And we're almost out of time, so switching back over to the exhaust system, what I wanted to show you here was the use of the XY plots. You'll notice I've got a sketch. I'm going to show the visibility of sketches. I've got a sketch line here in the outlet end of this pipe, and that line can be used in these XY plots to show you parameters of interest along that line. So I'm going to pick that sketch line, and looking along the length of that line, I want to see, for example, maybe pressure, velocity, and this mass fraction information. So as we had with the compare function before, we've got a nice visual of that information down here on the bottom of the screen, to where all those parameters that I've picked are plotted along the length of that line. So at the center line of this outlet area here, I can look at those parameters along that line. One of the nice things about this is I can export this information to Excel. And you see I get my Excel window pop up for me here. And that directly opens up within the Excel program with all the plots that I've set up. So there's my mass fraction of the exhaust gas going along the length of that line. So you can see that the concentration goes down for that. And then the mass fraction of air, you see that go up slightly. And then the overall velocity, slight increase as we go along the length. And then finally pressure, a little bit of a pressure drop there at the transition area. And we get the plot data as well. We get all of the information that was used for those plots. So this is extra post-processing capability here with the raw data itself. So some nice interaction there with the Excel program. All right, so that wraps up my presentation today. And I want to thank you for attending it. If you have any technical questions about flow simulation, including the topics that I just covered in this webinar, please contact us. We'll be glad to help answer any questions you might have. Thanks for your time. Thanks very much for joining us, and I hope this has been an informative webinar. Have a good day.